Focus of this video, once again, distance, rate, time, word problems. Just to review, here's my basic formula. D for distance, R for rate, T for time. The formula will be applied to objects in uniform motion, meaning movement without changing speed or rate. So we have three problem types: opposite direction, same direction, which have been taught in previous videos. The focus of this video is the round trip. And let's discuss what that means and then do some example problems so that you can have exposure and gain confidence with this. So the round trip is basically just what it says. You know, you start at home, you drive to school, and you take the exact same route right back. So you're driving the same distance, you're taking the same route, you're going to and fro, back and forth. So you can probably already tell that this is just simply going to be the rate time going will be set equal to the rate time returning, since you are covering the same distance with both trips, both legs of the trip. Let's move to your notes, just so you have a complete set of notes. So each problem type has its own setup, and this particular setup is going to be the same as the same direction problem type. So here for the round trip, rate time going is equal to rate time returning under the assumption that you are taking the exact same route. And let's do the problem that is in the notes, if I can find it here. Yes. All right. So we're going to do this problem in your notes, and then we're going to do a few problems from the Kuta set, and then that will be it. So here for this particular problem, as I get reorganized here, for this particular problem, here we go. Sam hiking up and down the hill. So I've got my chart set up, rate, time, distance, and I will label one row as up and the second row as down. He's hiking up the hill at a rate of 4 kilometers per hour and back down at a rate of 6 kilometers per hour. Total hiking time back and forth, both legs of the trip, total hiking time is 3 hours. So if I choose to let up be t, then the time coming back down is 3 hours minus t. And then, as I said, you're going to set both of these equal to each other, since we're assuming he's taking the same route up and down, just different time, or he's covering the same amount of territory, just at different rates here. So I take each of these, setting them equal to each other, and this is the equation that I end up solving. So therefore t is 18 over 10, removing their common 2's. That gives me 9 over 5. And to interpret that to time, well, I guess I could, no, I'm just going to go ahead and just clean this up. So to interpret that to time that makes sense, this is going to be 1 hour and 4/5 of an hour. 4/5 of an hour, if I multiply this by 12 to put it into units of 60, that's going to be 1 hour and 48 minutes. So t itself is 1 hour and 48 minutes. So that means that it's taken him 1 hour and 48 minutes to climb up, 1 hour and 48 minutes. And then if I subtract that from 3 hours, it took him 1 hour and 12 minutes to hike down. So up 1 hour, 48 minutes, down 1 hour and 12 minutes, just this fractional portion of time. Let's move to the Kuta problem sets now, and they're in topics. So once again, I've got the round trip problems and set up just like the other learning problems were set up too. So let's go ahead and do number 1 from the Kuta set. So problem number 1, let's see, Michaela drove to the train station and back, so I've just got it labeled to and return. And it took 3 hours longer to go there than it did to come back. So what that looks like in my problem, let's see, let me read this again and get myself set up here. 3 hours longer to go than it did to come back. So if I let the return portion be t, that means that the portion going to the train station is t plus 3, and then her rates are directly given. The average speed on the trip there was 22 miles per hour, and the average speed on the way back is 55 miles per hour. So there, going to the station is 22, Coming back is 55. And the model here is that the trip going, the distance covered is the same distance covered on the return portion. So this is the equation that I end up solving. And you see that T is 2 hours. So that means that it took 2 hours on the return portion and 5 hours driving to the station. 2 hours and 5 hours. And let's move on now and look at problem number 6. So I've got number 6 set up, and here are the words. Beth is driving to the lake, back and forth to the lake. On the trip there, she traveled 65 kilometers per hour, return trip 26. How long did the trip there take if the return trip took 5 hours? So this is actually easier than the example problem that we did, the very first problem we did. So I've got 65 and 26 in my rates, 5 on the return trip, and this is just simply straight up going to be the variable t. I set these two equal to each other, and then you discover that t is 2, so that means that's 2 hours. 2 hours to drive to the lake. And let's move on. Let's do number 12. I want to do 2 more just to make sure that you're good with this. So number 12. And let's see, so she's driving to her, this is Gabriella, driving to her friend's house. The trip there took 5 hours and the trip back took 3 hours. So 5, to drive to the house 5, to return from the house 3. And let's see, continuing with number 12, she averaged 16 miles per hour faster on the return trip. So that means I'll let this be R. I'll let this be R plus 16. And then I set these two equal to each other. And I solve, and R is 24. So that means that it took, let's see, she was traveling there at a rate of 24 miles per hour. And then her return trip would be plus 16. Her return trip would have been 40 miles per hour. And then let's do one more. Let's do number 20. And the wording in number 20, by now, this is probably pretty understandable because they all kind of become the same when they're at this basic level. Let's see, 3 hours less time to get there than it did to get back. So this is a train, and the train, let's see, the train was traveling at 80 miles per hour one way, and then the average speed on the way back was 50 miles per hour. So my rates are going to fill in 280, return portion 50. And then here it says that it took 3 hours less time to get there than it did to get back. So that means that if I let this be t, this is going to be t minus 3, 3 hours less time. I set these two equal to each other. And solving this thing out. And then you're going to end up with t is 8 hours. So that means that this portion of the trip was 8 hours and the other portion of the trip was 5 hours. So the return trip, different rates, different amounts of time, and that's basically it. You've now got everything filling in your chart. You understand the scenario with everything and reading these, so you've now had exposure to the basic problem types, the different setups, and that's the beginning of our unit.